Look at the next 10 MCQs of paper 1, right? So if you look at question number 6, there has been frictional force between these two objects, right? Now when you start to drag this with a force F, you should understand the frictional force acting on this block would be in this direction and on this block would be in the opposite direction, right? Now they have given us the static frictional force and dynamic frictional force. Now if you understand the frictional force is exerted between these two surfaces, right? So when now they are of equal masses A and B. Now when you drag with a force F, if this object A does not slip on B, then you're going to have static frictional force, right? Now obviously we have learned static friction as a force where the object doesn't move, but as this is the frictional force between these two surfaces, when there's no any relative motion of A with respect to B, we are going to consider static frictional force, and when A is going to be moving relative to B, we are going to have dynamic frictional force, right? So both of them are going to be the same frictional force, right? F, right? In the first case, you should understand the acceleration A is common for both of them, right? Because why? The static frictional force is acting, right? If you consider the entire system, the frictional force cancel off each other. We would have F divided by 2m as our acceleration, right? But in the next case, there would be a relative motion of A with respect to B, right? Now when you drag with F, okay, let's say there's going to be moving with A1, right? It's going to be moving with A1. Now you're going to have a relative motion, right? So you should understand your graph is going to look like this. There would be a high acceleration for A compared to the initial stage. Advance in the next case, right? So let's have a look at question number 7. Now in here, a 5 kilogram object is placed in a surface with a frictional force as 0.2. Now this is going to be static frictional force. Sorry, frictional coefficient. So the frictional force acting on him is going to be 10 Newton, right? And this object has been dragged with a particular force. Now that force has been given with a graph, okay? Now you should understand only at the instant of 10, when the force is equal to 10, this is at the verge of moving, right? And from then on, this object starts to move, right? So 10 is going to be our point. Now anything after 10, this object is going to be moving, right? So we have to consider the only area under this, right? So you should understand, now this is also similar to a question where a person with a certain mass is on a scale. So you're going to be so the scale is going to represent the weight of the man, right? Now when he is ready to jump, he used to exert some force on here. Now we used to consider that area only that extra force, right? Now that was question in a past paper. So we have to get into this idea. So any force after 10 Newton has to be considered for the motion, right? In order to consider the velocity. So you can see if it is 20, the time has been 4. So if it is 10, the time has to be 2. The gradient is 5. That's the idea, okay? So the next 10 seconds. So from 2 to 12, right? Right. Now let's find the area of this, okay? Half times, you can see 10 plus 8, 18 times the height is going to be 10. From here, you would understand the impulse is going to be 90, right? Now the object is initially at rest. So what's going to be the velocity? 5 times the velocity is supposed to be equal to the impulse, 90, which means velocity is supposed to be equal to 18 meters per second, right? So that's going to be the answer for question number 7, right? So also check this question, okay? So let's come to question number 8. Now in here, there are 3 equal volume rooms. Initially, they are closed. They're saying us the absolute humidity in room B is going to be S, right? And when they open the chambers, the final relative humidity was Y percentage, right? Now you should understand there's no any change in temperature. So the saturated, now if you consider the absolute, now we are dealing with absolute humidity. So saturated absolute humidity is going to be the same in both the cases. So if I understand as rho naught, here also it's going to be rho naught. So you should understand y percentage is supposed to be equal to S divided by rho naught times 100, right? This is going to be our equation. So from here we can get an expression for rho naught as S divided by Y times 100. Now if you consider in this case, the entire volume is going to be 3V, right? So saturated mass is going to be equal to 3V. Now ms divided by 3V is supposed to be this answer. So from here we can say that 3Vs divided by Y times 100 is going to be the saturated mass. If I want to make it saturated, that means relative humidity as 100, we should have 3Vs over Y times 100, right? When you have such a mass, you are able to saturate this, right? Now they are asking us what is the additional mass we are required at. Now you should understand the absolute humidity in the system is going to be S, right? So the mass present initially is going to be 3Vs, right? If I want to saturate it, I have to make it this way around. So when you subtract, you are going to get the additional value, which means 3Vs. If I take in common, I'm going to have 100 over Y minus 1 as our answer. So now let's have a look at question number 9. Make sure that you're going to take this as a theory, right? Now for closed tube, you should understand, usually you used to consider the overtone number 1, 3, 5, 7. The order which you will move is 2n plus 1. Now you see, look at the first overtone. First overtone is going to be 3. So 2 times 1 plus 1 is going to be 3. Now if you consider the second overtone, we used to consider 2 times 2 plus 1, right? So this is the way how you're going to find the harmonic number. Now for open tube, it's going to be n plus 1. Now n plus 1 is also same for the strings, right? So make sure that you're going to have it as a theory. So if I write an expression for this, see the frequency is equal to V divided by 4L times the harmonic number 2n plus 1 is going to be for closed tubes, right? And you should understand this is also equal to V divided by 2L times n plus 1, right? So from here we would obtain that 2n plus 1 over 2 times of n plus 1 as our answer, right? So this is going to be for question number 9, right? So let's have a look at question number 10. Now the statement which has to be present additionally is going to be the distance from the eye to the lens is going to be 2.5 centimeter. Now before the usage of a lens, the near point of the person was at 37.5. Now if he's a far-sighted person, his far point is going to be anyways at infinity. Now what he's actually doing is, by the usage of a lens, the near point of the man has been at 27.5, right? So from the lens, it's going to be at a distance of 25, right? So the person actually tries to make sure that if an object is placed at 27.5, he's able to look at that. So the lens we are using is going to shift the image to 37.5 so that he can see it clearly. Now what about his far point? Now far point was actually at infinity. Now by the usage of a lens, the far point is going to be somewhere around here, right? So if I place an object around this point, by the usage of a lens, the object is shifted onto here, right? So any object which is placed between these two locations is going to be visible. If I'm going to place the image at somewhere on here, again the image won't be possible. We have to use another lens. So the near point after using the lens is going to be 27.5, and this is going to be his far point after using the lens. So make sure that you're going to get that theory, right? So initially we have to find the focal length of the lens. So 1 over, now you should understand 27.5 from the eye, from the lens it's going to be at 25. So any object which is placed at 25 has to be moved to 35, right? 37.5 is from the eye, from the lens it's going to be 35. So 1 over v minus 1 over u is equal to 1 over f. From here you can get that image is going to be at 35 minus object is going to be at 25, the focal length f, right? Now we have to find the far point of this object. Again, if I plug into the same equation, image is going to be at infinity. The object is at its far point. Let's say this distance as d, which is supposed to be equal to 1 by f. 1 by f is 25 minus 35 minus 10 over 35 times 25. So this is going to be 0. From here we can get that d is supposed to be equal to 35 into 25 divided by 10, which means it's going to be at a distance of 87.5. Now 87.5 from the lens, okay? So what's going to be the distance from the eye? It's 87.5 plus 2.5, which is 90. So the object which is placed at 90 centimeter after wearing the lens is going to be his far point, right? So let's have a look at question number 11. Now there has been two waves given for us, right? And this point has been given as 0.25 seconds. If you actually find it out, the object is going to be the starting point. So if we end up, it's going to be t. So we have to find that how many periods has lasted along here. So when you count around them, you would see that it is 8t and this would be at 11t. So first of all, we should find the periods of both of them. So 8t is supposed to be equal to 0.25, right? So t is supposed to be equal to 0.25 divided by 8. Now what's the frequency of this object? Frequency is 1 over t. So from here frequency is supposed to be equal to 8 over 0.25, which means 32 hertz. Similarly, if I use on to here, t naught is supposed to be equal to 0.25 divided by 11. The frequency is supposed to be equal to 11 over 0.25, which is 44 hertz. So what's the beat frequency hertz? 44 hertz minus 32 hertz, which is going to be 8 hertz. Right. So now let's have a look at question number 12. Now this is going to be Z, X and Y. Right. Now what they have actually said us here is X and Y of equal masses. Right. So let's say mass of X is equal to mass of Y is equal to simple M. And let mass of Z be equal to M dash. So you can see that the weight which is along here is greater than at here. Now this is going to be M plus M dash G. This is going to be Mg. So this object is going to be moving upward and this object is going to be moving downward. Right. Now you can see after some time at the point B, Z used to get stuck in the ring Q. So after some time only X and Y used to be moving. Right. So initially if you find the acceleration, M plus M dash G minus T is equal to MA. Sorry, M plus M dash A. Similarly, you can see Mg, T minus Mg is supposed to be equal to Ma. If we add both of these equations, we would get that M dash G divided by M plus M dash as our acceleration. Right? And After the mass Z is removed, you can see X and Y used to have the same weight. Mg along here and Mg along here, right? So there will be no any resultant force. So after B, you can see from A to B, the acceleration is going to be this one. From B to C, acceleration is equal to 0, which means it's traveling at constant velocities, right? From C to D, now at C the string is going to be removed, right? That means it's going to get cut off. So from C to D, you should understand whatever velocities they have acquired, Y is going to be moving upward and again reach back down. X is going to be moving downward. But you should understand they are going to be moving under gravity. So from C to D, acceleration is under gravity. So if I had my VT graph, X accelerates, X is going to accelerate, Y is also accelerating. Both used to have the same gradient, right? Then they are going to travel with constant velocities as acceleration is 0. Now, X used to accelerate under gravity. Now you can see this value is a value which is less than G. So compared to him, the gradient has to be large, right? Now Y used to move under gravity. First of all, it used to move in the upward direction and then in the downward direction. So this way. Now you should understand these two has to be two parallel rays. Because why? The gradient is going to be G, right? So this is going to be our answer. Let's have a look at question number 13. Now in here, they are saying us the gravitational potential energy drop during the first second is going to be 20 joule, it seems. What's going to be the gravitational potential energy drop in the second and the third second, right? First of all, we have to find the distance traveled by them, right? Make sure that you're going to have it as a theory. The ratio, every time the ratio is going to be 1:3:5. Because why? If I apply S is equal to ut, during the first second, it's going to travel with initial velocity is 0, let's say. So half times A. In the next second, it's going to travel half times A, 2 squared is going to be 4, minus half times A. Why? Because this is going to be the distance traveled in the first second. This is going to be the distance traveled during the entire 2 seconds. So the distance traveled during the second is going to be 3A by 2. And in the next is going to be 5A by 2. So every time the ratio is 1:3:5. So the gravitational potential energy drop in the first second was 20. In the next it's going to be at 60. And then it's going to be at 100. Right? So this is going to be our answer, 60 and 100. So let's have a look at question number 14. Now you should understand this is going to be the starting point. So if it is t is equal to 0, exactly at this point is going to be at t, right? And this point is going to be t by 4. This point is going to be t by 2. And back again 3t by 4 and then t. Now what they have said is the frequency at some points, f1, at this point it is f2, and at this point it is f3. You should understand the object is at rest during these two locations. So f2 is equal to f3 is equal to whatever frequency given by him, f. Now when at t by 4 shift this pathway, you can see the direction is downward, right? So from here you can see that it's moving away from the source. So f1 is going to be a frequency less than f. So our answer is supposed to be f2 is equal to f3, which is less than, sorry, which is greater than f1, right? So let's have a look at question number 15. In here you should understand, and make sure that you're gonna look at the actual diagram. I just consider only the boxes here. So you can see we are having a force along here along here. Now this point was named as A and this was named as B, right? So you can see that the horizontal component is supposed to be equal to two boxes, actually 2 units. The vertical component is supposed to be equal to 2 units. Now this is a force which is inclined. If we consider the vertical component of this, it's going to be again 2 units. If we consider the horizontal component, it's also going to be 2 units. So there would be a upward force equal to him. And there would be a horizontal force in the positive x direction equal to him. So the resultant force is supposed to be equal to 0, right? But what about the moment? If I take moment around A, you can see the force along here and there's a force along here. So these both used to cancel off. But there would be a moment caused due to him, right? So you can see that linear acceleration, because why there's no resultant force, linear acceleration is supposed to be 0. But there would be an angular acceleration, right? Angular acceleration is not equal to 0. There would be an angular acceleration.